how do I describe the components of a scientific investigation? When you visited our website, you have seen the same essential question in our Essential Question Learners Material or EQLM. This is what I am referring to when I say EQLM. And this is our first lesson. This essential question is based on the DepEd's K to 12 competencies. Okay? Now, to answer this essential question, we have several supporting questions here that would consolidate to empowering you on how to answer this essential question. Now, what is the main concept of our essential question, Hazel? So what is the key word in our essential question? The one that we need to accomplish.
Components of a scientific investigation.
Very good. We're talking about the components of a scientific investigation. In order to accomplish a scientific investigation, we have to follow a certain procedure. What is that certain procedure? Lead. Very good. Again, in order to perform a scientific investigation, we have to follow the step of the scientific method. So this is the scientific method. And it's one of the vocabulary words in our word cloud. How many of you have took the liberty to check what a word cloud is? Did you check online, in YouTube, or in Google? Did you? Okay, so what did you learn? What did you learn about a word cloud?
You basically put words in different colors and sizes in form an object.
Okay, so that is one of the concepts.
I
Yes.
found all the word clouds in YouTube in the computer like Photoshop. I didn't find them in Facebook.
You found them in YouTube. And it can be done manually or you can do it using the computer. Okay? But I prefer you doing it manually. Okay? You need to do it manually because I want to prevent somebody else from doing it for you. That's why it should be done manually. Maliwanag po ba yun? Okay, let's continue. When you are dealing with a certain problem, and that is where you conduct an investigation, you only conduct an investigation when there is a problem. Can you solve a problem? Yes or no, Ariana? Yes. But before you can solve a problem, what is the first thing that you have to know? Yes.
The problem itself.
Very good. You have to know the problem itself. So the first step in the scientific method is to know the problem. That's the first step, or this is the first step. You can never solve a problem unless you know the problem. Let me give you one example. There was this child who came to me a few years ago, and he was crying. He told me, Mr. Rangan, I'm really having a hard time at home. Whenever I get home, my mom always nags me. She always tells me all of these things that are just repeated over and over again. She even tells me that I should not eat. She even tells me that I should not go home anymore. That happens every day. Then I ask him the question, so you feel that your mom doesn't love you? And he replied, she really doesn't love me. So I have asked him several other questions in order to know the problem. I asked him. He was in 7th grade. I asked him, so what time do you go home? He answered, 7 p.m. Really? So when you reach home, how does your mother look like? My mom waits for me by the door, and she looks worried. But the moment that I step in the house, the worriedness becomes angrier. She starts nagging me. So, what time is your last subject in school, and what time do you go home? He answered, our classes ends at 12:30. So where do you go? I go to a computer shop to play Dota. And then I ask him another question. So, how much allowance do you have every day? Oh, my mom gives me 50 pesos aside from the transportation fare. So, the 50 pesos is for me, he said. So, your mother work? No, she's a housewife. My dad is a jeepney driver. So I told him, maybe your mom is not the problem. That boy can never solve his problem about his mom because he doesn't know the problem. Unless you know the problem, you can never do the scientific method. So when I told him, your mom is not the problem. It is your action that gives you the problem. If you get out of school at 12:30 and get home probably about 1:30 or let's say 2 p.m. because of projects, then your mom will not be worried. And that is the time that he realized that he was the one causing the problem. Okay? That is the significance of knowing the problem. After knowing the problem, what's the next step? Of course, some have 5 steps, some have 6 steps. So whichever we get, that is what we will be using. So, what you don't have, some of you don't have name tags. Tomorrow, if you don't have a name tag, then there will be a problem. Okay? Stand up, please. What's the step after knowing the problem? Again? Say that louder. Materials. So what about the materials? Anybody who can help him? What's the next step? Yes? Hypothesis. Before you can hypothesize, what should you do? Yes? Very good. Do a background research. Do background research or find information about the problem. That child found information about the problem when he talked to me. Do background research. After doing the background research, the next step would be the hypothesis. Okay, formulate the hypothesis. So this is the time wherein, based on what you've learned about the problem, now you formulate a hypothesis. That child learned what the problem was, so he would probably formulate a hypothesis by saying, maybe if I go home early and I stop playing Dota and do my lessons at home and review them, maybe my mom would no longer be nagging me. Maybe my mom would stop telling me all of these things. Maybe she would love me more. Okay, that's a hypothesis. Of course, there are a lot of names because it's just a plan on how to solve the problem. The other name for this, because of that, is intellectual. Yes. And after the hypothesis, that's the time wherein you gather. Before you gather the data, you have to do something. Yes. Very good. You test the hypothesis. Test the hypothesis. In one word, what is testing the hypothesis means? And you said the answer? Yes? You experiment. And this is where we go now. The process of experimentation. They will be performing an experiment. In an experiment, there are certain variables that we need to consider. The first one is the independent variable, and the second one is the dependent variable. The independent and the dependent variable are under the experimental group, or some would say experimental setup, or we can use the word group because that's the one that you get. It's acceptable. The other experiment or part of the experiment that is what you call, very good, it's called the control group. In an experiment, there should only be one IV or independent variable. Only one. The reason behind this is to make sure that this one is really the reason why the change happened. So, the independent variable is the one thing that you change so that you can study and measure what? Yes, ma'am. The dependent variable. And how do we describe the dependent variable? Yes, ma'am.
It's the variable that is being
Very good. The dependent variable should be quantitatively measured. It should be measurable using numbers. Okay? So to make it simple, we can say that this is the cause and this is the effect. And these two are under the experimental group. Now, the control group is only for comparison. Very good. Do we manipulate the factors in the control group? No. They remain as they are so that you can compare the changes that happen. Aside from this, we have what we call the constant. What are the constant, or you might say constant variable by others? What are they? Since you are only allowed to change one, the rest should not be changed, and we call them the constant. The constant are the things that remain the same throughout the experiment. In both setups or in both groups. Now, to demonstrate how experiment is done, we will be experimenting with the floating egg. Yes, sir.
Just want to ask if the experimental group will have that effect on the final outcome.
Yes. If I understood your question correctly, will the experimental group will have an effect on the? Of course, because you manipulated, so there is a change, or there will be changes. Okay? So, let's now perform the experiment. We have two cups, identical cups, and we have water. Okay? I will fill them both with water at the same level. Okay? And this one, and I will ascertain that they have the same amount of water. Okay, so they are both on the uppermost line, so they are equal. So same size, same type of cup, same shape. So that is one of the constant. The next one is that I will get the egg, the first egg, the second egg, they are almost identical. Okay? I'll put the first egg in the first setup. Okay? And then the second one on the second setup. So what did you notice about the egg? Did they float or did they sink? Yes, Faith. Okay, both of them sunk at the bottom of the water. Okay? Now, the next thing that I will do is that I will designate this as setup A and the second one as setup B. So, this is setup A and this is setup B so that I won't be confused. Setup A, setup B, and I have labeled them there. I will designate setup A as the control group, while setup B will be the experimental group. So, do I have to meddle with setup A? Do I need to manipulate it? No, because it is the comparison. It is the control group, and we'll only use it as a comparison. However, with setup B, which is the experimental setup, I'm allowed to change one thing. And that one thing is what we call independent variable. Okay, so I will now be putting salt as the independent variable. Okay. So that's the salt. Since I changed one thing, and that is the addition of salt, the addition of salt now is what we call as the independent variable. Now, I have two steering sticks here. I will now steer the experimental group, which is set up B. I will firmly hold the base to prevent it from toppling or spilling. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So I steer 25 times with constant speed of revolution. I will do the same thing with setup A, which is control, because I have to maintain everything else the same except for one. Okay? So, what I did here, I should do here. So, I will now steer this how many times? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay. Now, let me ask you, what are the things that remain constant in the duration of the experiment? One by one, from the back, stand up. Give me one that we maintain the same throughout the experiment. The steering. So the steering was maintained constant. So what I did in setup A was also done in setup B. Next one,
The amount of water.
the amount of water. The amount of water. The third one, next,
Same size of cups.
same type of cups. Okay, the cups are almost identical. Next, Aubrey.
The same type of eggs.
Okay, and the eggs. Do we have any other constant? No. So these are the things that we maintained the same throughout the experiment, and we call them the constant. Now, let us now go to the experimental group. Again, which is the experimental group? Setup A or setup B? Yes, setup B. In the experimental group, we have the independent variable. So what is the one thing that we change in setup B? Yes. Diyan. What's that? The position of the egg. Did we change that? Yes.
The salt or the amount of salt that was given or that was given to the setup.
Okay. The salt that was added to the setup, that is what we changed. We added salt in setup B. We changed that. Okay? So we call that the independent variable. Okay? I'll just get the ruler. It should be somewhere here. There it is. Now, let's go now to the dependent variable. As a result of the independent variable, what happened to the egg? Yes, the egg is now floating. Right? But is it enough to say that the egg is floating? When we defined dependent variable earlier as what? Measurable. Saying the egg is floating, can it that be described as measurable? No. So how can we measure the dependent variable? By ning, 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 ning. By using a measuring tool, and in this case, we'll be using a ruler. Okay? Now, at the beginning, where was the egg before the addition of the independent variable? Yes, at the bottom. And we will designate that as 0. And since we'll be using centimeter as our unit, that will be 0 centimeter as the beginning of the experimentation. Okay? Now, let us now observe the change. To measure the dependent variable, a ruler will be used, but in order to measure that, I have to push the experimental setup close to the edge of the table. Why do I have to do that? Because my measuring device, this side here is millimeter, and this side here is inches. Okay? And you will notice that the 0 in millimeter is here, while the edge of the ruler is here. If you start measuring from the edge of the ruler, then what we call that is systematic error. That means the measuring device was not used properly. In measuring, you should always begin at 0, not from the edge of the measuring device, as in the case of this ruler. Okay? This is a half rule, by the way. It's only 6 inches. Okay? This is a half rule. Now, how do I measure? From 0 centimeter, I will now position the 0 at the base of the cup. You see that? Now, I will use the same steering rod that I've used before to position at the base of the egg. Can you please help me and put this stick aligned with the bottom of the egg, and then you read the measurement in centimeter. Yes, at the bottom of the egg. So what's the measurement? 4. So the measurement is 40 millimeter. How do we convert that to centimeter? Okay, and what would be the answer? Very good. So, you would say that the height of the egg from what? From 0 centimeter, the height of the egg rose to 4 centimeters. Now, how do you now write your dependent variable based on the data that we acquired? Yes. Stand up. So what is our dependent variable? Our independent variable is the addition of salt. Let me replace that. Our independent variable is the addition of salt. Our dependent variable is from 0. Can anybody replace that? There can be several ways to state that. Yes, sir. Yes. Okay, that the egg flows as you identify the change in a quantitative manner. And that is what we call as the dependent variable. That concludes our experimentation, and with what we have learned, we have gathered what? What did we gather after the experiment? Yes, ma'am. Data. So after the experimentation, we have gathered data. And what do we do with this data? Yes, ma'am. Again?
Analyze.
You analyze them. Upon analyzing, what do you form? Yes. Okay. You analyze them and then you form a conclusion. Is there another step after forming the conclusion? Yes, sir. You have to report your conclusion so that you can save others time on doing the same experiment. If you performed it well, then others don't have to repeat it. Rather, they can use their time to conduct other experiments. Will you please stand up? You said earlier, when you will ask about the hypothesis, you mentioned the word amount. Am I right? But when I put the salt in, I did not measure. Am I right? So, in reporting or sharing your conclusion, you can actually recommend other things wherein other experimenters, other researchers, other teachers, other students can perform based on the word amount. What experiment can you suggest that others can do?
There are many experiments that requires the proper amount, like something like when we're speaking of amount, experiments like for example the paper making from papers. So if we don't have the right amount of water or paper ratio there, it will not form the proper paper.
Very good. That is an excellent answer. Take note. You can recommend others to perform an experiment to determine the proper ratio of water and salt in order to make the egg float. Do you get that? The importance of doing the experiment properly saves time. We did this so others don't have to do it. Instead, they can do other things based on what they have observed from your experiment. She mentioned amount, I disregarded the amount, and since she mentioned amount, now she can perform an experiment to actually determine how many grams of salt do I need so that I can make an egg float in water. Just like when you are making a paper, how much of these chemicals do you need and how much water do you need in order to actually make an actual paper? Do you see that? That is what science is for. That is why when you perform an experiment, you have to consider that others will be using your work as a basis on how they will continue their work. Hopefully, with this experimentation that we just conducted, you now understand the different blank of scientific investigation.
Different components of scientific.
Very good. So we have identified the different components of a scientific investigation. Tell me what are the components of the scientific investigation as our summary. Components. Give me one of a scientific investigation. You investigate, you experiment. Starts with the letter I. Can you give me one of the components of a scientific investigation? I said I, but there are so many of them. Investigate. Okay. Next. Conclude. Next. Information. Analyze. Gather data. Hypothesis. Conclusion. Remember, if they were mentioned, don't say it. Observe. Experiment. Background research. Ask questions. Mentioned. Mentioned. It's getting stressful. What else? Know the different variables. Let's go from there. Variables. Know its purpose. Variables. Know its measure. Variables. Okay, variables. Independent variable. We're going to the right track. Dependent variable. Control. Experimental. And the one that we don't change? In both setup, what do you call those things that we don't change? That we maintain the same? Yes.
Constant.
The constant. So those are the components of a scientific investigation. I hope now you are well equipped on how it is done. Okay? Thank you so much.